Hi, this is Grace, and this is my program. So I first made a box object for the wall. I gave it a position and a size because, it's still a box. And then I made a ball object using the sphere. I put it in -1 because I was gonna make the spring to have a length of 1, so there's that. And then I made the spring using a helix. I made it start on like 0, 0, 0, and made it obviously have the length of 1, so it connects to the ball, and then just kind of use the appropriate values for the height and width. I also redefined the axes so it points downward vertically. I had a lot of trouble with it, so I went to the GlowScript help website, and Jacqueline also helped me with the axes part because I was really confused. Oh no, sorry. And here are all my constants. Obviously, G is always that number. But the mass of the ball, the spring constant, and the initial length are all like subject to this problem. And the only variables I had was the momentum of the ball, so I can use it to update the positions later, and it's just P equals mv. The value for velocity, which is 0.2, -0.2, and 0, I just found it in that example program we did in class, so I just kind of carried it on. Obviously, T initial gets the value of 0, and I made each time step 0.01. So in the while loop, I only had to run for 10 seconds. Because like that was in the description, I think. And I made the rate 100 because it was kind of standard issue from all the summer work we did. L is like the length of the spring in a way. So it's just the position of the ball minus the position of the wall, so it's constantly changing. This line is just the formula for spring force. Magnitude of L minus L initial is the change in L, and L hat is just L dot normal here. The F net in the system is just gravity and the spring force, which we just calculated in the line above. And in this line 30, I am just updating the momentum using the PF equals P initial plus F net times delta T. Formula is basically the same thing. And then in line 31, I updated the ball's position using the future position gets the value of the initial position plus future velocity times delta T. Since the delta T is so small, I guess we can just consider it be future. And ball P here is the future value, so that divided by the mass of the ball just gives us VF. T obviously grows every time the loop goes over, and this part I had a lot of trouble because I know the x value in the helix size vector is like the length, but I could only, so I put the y value for the ball's position in it, but I couldn't make it swing left and right. I just didn't know how to do it. But here it is. Thanks.